Hello and welcome back. Well, this is part 2 of the drum sander build, and where we left off in part 1 was with the rig here on the bench, and there were a few more things that I needed to do to finish the project off. The first thing I want to do is I want to build the drum, and I'm building the drum out of this plywood which will be mounted on the spindle, and then I'll turn that round on the lathe to make it nice and round. Now, to hold the drum onto the spindle, I've made these collars in the last video. There's one here and one down the other end, but these are made of steel and I want to blue them before we put them onto the spindle. And I'm also going to blue the pulley that I made for the motor as well. I use this Perma Blue. It's a chemical bluing solution, and I've shown this in a whole bunch of other videos, so probably not going to show too much of it here. But those parts have been buffed up on the wire wheel, and I've also cleaned them off in acetone as well. So you've got to get all of the grease off them before you blue them. This solution works pretty quick, and once you're happy with how black the parts are, then they need to be washed off thoroughly in water. Once that's done, I thoroughly dry these parts with the air gun. And lastly, the parts are thoroughly oiled up, and that gives them some protection. Of course, I'll clean the oil out of the V for the pulley so that it doesn't slip. These are all the plywood pieces that we're going to need for the drum, and they've been cut to just over 100 millimeters square. For the first block, I draw an X in the middle, and that's where we want to drill our hole. I'm going to try and automate this process a little bit. So I've got the block in the vise here. I have a stop on the vise so that I can get the block in the same place. So basically, once this is drilled, this block can come out, and I can put the next block in up to the stop, clamp up the vise, and the drill will be right in the center of that block. And that's because I have the X and the Y axis all locked down in this position, and that my good friend Dick has cut these exactly to the same size squares. Let's drill the first hole. It came out pretty good, nice and clean. Then I tested on the spindle, and this is a very firm fit, but it is still able to be slid along the spindle. This is exactly what we want. Here's the production line. We drill the hole in a block, comes out. I clean off the parallels with the ear, and then put the next block on, drill the hole, that comes off, clean the parallels off, the next block on, drill the hole, and we do that all the way through. There's about 32 of these pieces of plywood to drill. On the right of the shaft you can see I've put the black collar on there, and the piece of wood is put right up to the collar. I use plenty of glue on the piece of wood. The next piece is slid on, and I just offset this a little bit. More glue goes on there, and the next one, and so forth. When I get about 7 or 8 pieces of wood on there, I clamp these up for about 20 minutes. I want them nice and tight. I keep doing the same process until I have all of the pieces of wood on, and they're all clamped up for another 20 minutes or half an hour. Then the clamps are removed. Then I put on the collar for this end here. That's pushed up against the piece of wood and all locked down onto the spindle. And then I screw in 4 50mm long screws. That's about 2 inches long. The first thing I did with the spindle was to put a center in one of the ends, because I knew that I was going to be turning this in the lathe, and that allows me to mount it properly and securely to turn. So we start cutting, and these are quite big cuts. It's not every day you see a 15mm deep cut on a metal lathe. Now, yeah, I know, we're not doing metal, but it's still not that common. Another angle there, we're getting close to finish size. And then we get down to size, and we're just doing our finish pass now. So this spindle is 100mm in diameter, at around about 4 inches. Well, apart from putting on the Velcro and the Velcro sandpaper, this drum and spindle is pretty much done. Now I know a few of my wood turning colleagues would say, "Hey man, you're cheating. Why don't you do it like a man and put it in a wood lathe? Use some wood chisels and make it flat." Well, if a wood lathe is all I had, then that's what I'd do. And I know Dick down at the club, he talks about wood turning and doesn't need to be 3 thou within a whatever, but I'll tell you what, this spindle is dead flat. The next job I want to do is add more support between these left and right pillars. And I've got this piece of angle iron, so I'm going to put it in here, up on some spaces, because there's some welds in the corners, which I can't really avoid. And that's going to give it a whole bunch of support. Now it's not going to interfere with the sanding dust because it's going to be coming in on an angle like that. That piece of angle iron is tacked in place, and then I come back and put some more significant welds in there. Right, now the next step is to fit the motor. I'm going to use a bit of the 60mm bar. I'm not going to use that linear guide because it's not going to really work for us, but I'll make some little standoffs at each end here, and that bar will fit in those. This is 25mm bar. I'll bore a hole for this smaller bar to go into. That'll work as a hinge. And that hinge will be welded to a plate which is bolted onto the motor. And that will allow us to rock it back and forth to adjust the belt and also slide it sideways so that we're able to put the belt on different pulley sizes to change the speeds. The hinge piece is a very simple part. It's just a bit of this 25mm steel drilled out and reamed out to 16mm. I clean the bore out and test the part in there. This is a very, very nice fit, so I'm happy with that. I found the scrap of 1/4" plate which will do for the motor plate. I need 100mm this way, and I'll get that within the bolt holes here. And I need 180mm this way, but I have 190, so that's fine. There'll be a hole in the middle, but that's no problem. I cut strips off the plate where those bolt holes are, and that's all done pretty much off camera. Now I'm working out where the bolt holes are going to go for this motor. They get center punched. Then those are drilled out to 8mm. I'm going to use M8 bolts here, so just bolts and nuts. We're going to keep it simple. We're not going to thread any holes to screw bolts into. The motor goes onto the plate like that. Put on the washers and the nuts. Those are all tightened down with a spanner. Then it's moved into position. Now the bar needs to be spaced up. Actually, it needs to be a bit higher than that. So another spacer. It's going to be around about there somewhere. The motor will come in, and I'm going to weld that round hinge onto that motor plate. I have it all set up on the bench here, and I tack the ends to begin with. Then I run some welds on each side. Those are cleaned off, and that looks strong enough. I didn't say it looked nice. Here I'm tacking on the bolt heads for the bolts, so I don't need to use a spanner when I tighten up the nuts. Now the smart ones watching will probably be rolling along the floor laughing their heads off, and that's because I made a huge mistake here. I've actually bolted the motor on the wrong side of the plate here. These are all later cut off with the angle grinder. I've got some new bolts, and this time I actually bring the motor over to the machine and just make sure it's configured correctly before I weld the bolts. And then I tack on those new bolts. I've set the motor out 1 inch from the edge of the machine and the hinge. Then I need to make up 2 standoffs which will be 50mm long. Those standoffs are cut out of some 20mm thick bar, and that's just over 3/4 inch. Both those pieces are milled at the same time, and that way I know they're exactly the same height. The next step is to drill out and ream a 16mm hole, and that will be for our bar to go through the middle. The 2 standoff blocks are done. They're put onto the bar. The motor's moved in, and it works like this. Now I have a little bit of an issue here. This block will be on the edge here where that white line is. So I'm going to have to put another piece of metal in here. This is a piece of 5mm thick flat bar. And once these blocks come in, then that looks pretty good. Now I need to clamp and weld these blocks onto this flat bar, and I'm going to be drilling holes in here so that I can screw the flat bar to the frame. Then later on I'm going to be chopping the flat bar here and here, and that will give me 2 brackets. I think that's going to be helpful to make sure the bar is nice and smooth in those standoffs. I tack that standoff onto that flat bar and also put a tack over there. Now that tack is just temporary, and it's going to allow me to drill the holes through both parts, and then I'll grind those off and separate the piece away. I've also done the other side and finish welded everything here off camera. Here I'm drilling up the holes. These are 8mm holes for M8 bolts. I grind off those 2 little tack welds. The left hand side is separated but the right hand side isn't, so a bit more there, and then that comes off. Next I cut the centre out of that piece of steel, and that gives me 2 brackets. Now I was having a bit of a hard time with this. Although I had flexibility on the brackets, this bar was really tight. But good news, after fixing it, these are locked down and the bar slides in here very, very nicely now. I can also rotate it, which is part of the design. Now the issue was that these standoffs here had got pulled in with these corner welds, so I had to get Big Bertha out and do a bit of manipulation on it, and that worked fine. The rod goes in here, and I've put a washer and a bolt on the end here. That allows me to work out how much I need to chop off on this end here. That's chopped off with the angle grinder. I tidy the end up on the lathe. I drill out a hole so that I can tap it to M6. The motor is put back in place. The belt is put on. Screws are added at each end so the bar doesn't come out. In terms of operation, we just lift the motor up and move it across, and we can put the belt on the other pulley. Now we're not quite done. There's 2 small things we need to do. I've got to stop the motor sliding, so I'm going to tap a hole in here and put a grub screw in there to go onto the bar, and that will allow us to keep the motor in line with the pulley. And then I can loosen the grub screw off, move it across, lock it down again, and of course I'm going to have to put some flats on the bar underneath. Now the second thing we need to finish off here is a way to tension the belt. So I need a little jack type thing in here to push onto the plate, but I need it to work when the motor's in the different position as well. So that's the next job. I mark out where I want to put the grub screw. I drilled the hole off camera, and now I'm tapping for an M8 thread. I align the belt to be parallel with the pulley edge, that way I know the motor's in the correct position. Then I screw down the grub screw to make a mark on the shaft. Now the issue is the shaft is case hardened, so this doesn't work. In fact, even a center punch in there did not even mark the shaft. So in the end I just had to measure from the end of the shaft the 3 locations. The 3 locations are cut on the milling machine. I'm using a carbide cutter to try and get through this case hardened steel. There's the 3 things there. There's one hidden underneath. So the motor gets pulled along and we can actually look down the hole, put the grub screw in the right place, and then lock it in place. The belt goes back on. Then I check that alignment. That looks pretty good to me, and I do this for all 3 locations. The next step is to make something to tension the belt, and I've got this piece of square, about 12mm thick, 1/2 inch. That's going to get welded to the side there. Then I'm going to drill and tap an N12 hole through there, and I'll be able to put a bolt in there and then jack against the plate of the motor here. This is a simple part, just needs to be drilled out and tapped to M12. The part is clamped in place. I first tack it and then fully weld it off camera. Once it's cooled down, I place a bolt in there and I test out the mechanism, and it seems to work really well. The belt has quite a bit of tension on there. That said, I am going to have to buy a smaller belt because when it's on the smaller pulley, the motor leans away too far. We give it another test. That works great. The weather's not too great outside today, so I cut this baseboard off camera, and now I mark out where the bolt holes need to go. There's 3 on each side. It's a little bit tight to get into the space, so I'm using a right angle drill, and I'm drilling a pilot hole to begin with. That allows me to tip the machine up on the side and drill right through from the bottom, and drilling those holes out to 8mm. I have the machine clamped in the right place on the board, and then I drill through that hole and through the board. Now I ran into this problem where my drill bit is too long, so I'll have to find a shorter drill bit. I found an unbranded drill bit and I just cut it short, and that seems to work pretty good in here now. So I can get right through the board there. A bolt and nut is put on there. We tighten it down. Then it allows me to remove the clamp from this side, drill through the next hole, and then fit the second bolt and nut on the end there. The machine is bolted down to the baseboard, and before I go building sides and things like that, I really want to build the top, because the top needs to be in a specific position in relation to the drum. Once I have the top made, I'll be able to build the sides and any other supports for the top. Now the only piece of flat MDF that I have for the top is this piece here, and this is 30mm thick. So it's quite a thick piece of wood, which is going to probably add a bit more weight to this machine. Now I need to make this board sit on top of here properly. I can see straight away there's bits of steel here and here which are too high, so I need to cut those off. There's also bearings in here we need to route out in there, and the pulley is in the way as well, so that needs to be routed out. Also, I need to cut out a slot for the spindle. I've marked off where I need to cut this bit of steel which is too high, and that's cut off with the angle grinder and tidied up off camera. Now I've drawn up a plan here. This board is actually upside down, so we're going to draw on the bottom of the board, and it all works from this edge here. So all the measurements come from this edge, and the first one is 80mm will come in, and this is the point where we would start cutting our slot out. Our 50mm slot going across. There is a wider slot there too, but those edges are 45 from the inner slot. Then of course we've got our length of the slot, and at that end there I've left the board long at this point, but I'm probably going to have to chop it off to the right width. Off camera I've marked out the board. I just transferred the measurements from the plan over to the board there, and the first thing we'll do is we'll cut out this 50mm slot down the center, so I need to go to the table saw to do that. I'm raising the blade, but this line here is supposed to be lined up with this line on the fence, and I'm in the wrong position. So the blade is actually cutting into the edge of the wood, and I only realised it once the blade had come through the top, so that was a major screw up. Anyway, we're back on track here, making just parallel cuts for the slot, and this time I am lined up in the right place. Once the 2 cuts have been put into the board, I use a drill and then come back with the jigsaw to tidy up the rest of those cuts. And that's it, the slot's been cut out. This is the top, and man, I am really pissed off about that. This is the second phase where we cut on a 45-degree angle here. I'm using the same process as what I did before by raising the blade on the table saw. Now because I can't get the blade right to the end of the lines, I finish it off with the handsaw. And the ends are cut with a multi-tool to get those pieces out. That's the slot pretty much done. This is the underside, and this is the top side of the table. This is where the wood will be run over the drum, and it looks pretty good apart from I placed the top board on top of the roller, and you can see that the roller is still quite a distance below the board, and that's because there's bearings at each end that need to be cut away in the board. I mark out those locations with the board sitting on top. Then it's back to the multi-tool to cut these bits out. And basically the bearing is round, so I sort of just got to scoop out the center here. I tidy up the edges with a bit of sandpaper. And there are the two cutaways which are now complete. The table is fitting pretty good now, so I use a ruler and the drum is actually poking up just a fraction, which is good. We will have the tabletop a little bit higher once we fit it all up, so the drum will be actually slightly below the top surface. Now we have this mistake to deal with, and I was going to do this anyway to strengthen up the table, but I'm going to put some angle iron on the outside here on both ends just to strengthen that up a bit. Other videos on YouTube show them putting angle iron underneath, but I don't have any room for that on this particular design. Now there is still quite a bit to do here. I've got to build all the sides up. I've got to put a hinge on the top. I need to have it adjustable so that we can adjust the roller through the center slot. And there's also some guide vanes for the dust to put inside and dust collection port to add as well. This video here has gone over 20 minutes again, so I'm going to stop it here as part 2 and we'll complete this build in part 3. I hope everyone has a great day, and once again, thanks for watching.